Welcome to Chapter 3 of Screen Design in Adquio. This chapter will be divided into two different parts because it will be a content-rich chapter, and otherwise, it would extend to over an hour. Therefore, you are currently in Chapter 3.1, where we will cover the most basic components for user interface editing with Adquio. In the next chapter, we will look at advanced controls. Let's begin. In this chapter, we will go through all the possible objects you can use to design your interfaces, and above all, we will focus on the details of the objects that we find most interesting and useful. As you may recall from the previous chapter, we used a potentiometer and a switch for the initial examples. In this case, we will start in order to review all the objects that could be useful in our designs. Let's start with LEDs. LEDs are very useful for indicating whether a signal is active or not in our design. For example, if we are displaying an error list, we can show a red LED when an error is active, or simply, if we are showing a circular light, as in this case, we can use one of these LEDs in the color of our choice to indicate whether that light is on or off. Because as you can see in the lower section, it tells us the conditions under which this LED will be shown as on, and the conditions under which it will be shown as off. We are going to connect it as we did in the previous chapter to our Adquio light. We will connect it to the same unit and assign it the same address so that you can see it clearly. Then we will set it to the default. I think this works for us, since we are testing with this variable with values of 0 and 255. Here it tells us that it will be on when the value is different from 0 and off when it is equal to 0. Therefore, a value of 255 is different from 0, so the LED will be shown as on. When we say animation, it means that this LED will blink if we click on it. Let's look at the variety of LEDs we have available. As you can see, we have several colors: yellow, green, red, blue, cyan, orange. Then we have specific icons: a motor on, off icon, a plug, a fan, a light bulb, a desk lamp, a presence detected indicator, an open door indicator, a window, a danger indicator, a direct alarm indicator, an intrusion indicator through a window, a running or stopped pump, and even a fire indicator. These icons can already be very useful as they are. Let's remember that we always have the option to upload our own icons, and we should always upload these icons in pairs, one for the inactive state and one for the active state. Later on, we will do an example, specifically not with icons, but with buttons, for example. But it's the same process. How to design a button, in this case, an indicator, to show if it is off or on. As mentioned, for two states, we will need to create an image for the LED off state and an image for the LED on state. The important difference between this object and buttons is that this only displays information. In contrast, buttons can show whether they are pressed or not, but they also allow us to press them. That's why they are called buttons. Let's select a button, for instance, a yellow one, which I like, and let's choose a size. This one is too large, so 40 pixels would be a contained and quite suitable size for our screen. Here we have the LED diode, and we are going to test it. As you can see, when we turn it on and off, the switch lights up and the LED turns on and off. Since we're here, let me show you some additional details we can configure in this editor. As you can see, when we move the objects, they move along these grids. This is the grid we have in the background. If we needed to adjust the elements more precisely, say for example, if we wanted to place this LED closer to the switch without touching it, as you can see, we currently cannot do that. We can choose the size of this grid here, and instead of 20, we could set it to, for example, 5. This gives us much more precision for design, and now I can move it much closer without touching it. Okay, this is an interesting feature that provides us with more functionality for design. Next interesting object. We've seen the switches. Let's go back in. As you can see, we also have a lot of them available. As we mentioned in the previous case, they must have two states, pressed and not pressed. Okay? And let's take this opportunity to review some more important details about these buttons. As you can see, for these buttons, we don't have the option to upload our own, but we can choose from the existing ones. Later, we'll see another option to create these buttons. Okay, let's select, for example, a button of this type to make it different from the ones we already have. We will connect it again, just like we did in the previous cases. Okay? Now let's look at several of its features. First, let's set an appropriate size, and then explore the possible functionalities. It can be a switch, a push button, a button to turn something on, or a button to turn something off. Great. What's the difference between these four options? It's very interesting, because this gives us a lot of power depending on the type of interface. A switch is a button that, when pressed, stays in the position we leave it in. So a switch can be pressed to turn on and stays on. We can press it again, and it will switch to off and stay off. So the switch goes to a state and remains in that state until we press it again. In contrast, a push button is a button that sends a message when pressed, but stops sending the message when released. For example, if we connect this button to one of our variables, it will send a value of 255 while pressed, but as soon as it is released, it will send a 0 again. This is important because in many situations, we are interested in simply pressing a button to activate something and having it deactivate when released. We will test this later. Additionally, we have buttons that turn something on and buttons that turn something off. This means that this button only serves to turn something on or off, and it will stay in that state. We need to change that state with another tool, but this button will not be able to return to the previous state. For touchscreens, the most commonly used are the switch and the push button. Within the value type, you will see that we have number and bit. In our case, we will always use number because we don't want to complicate things by using bits. In the Modbus protocol, it is possible to use the 16 bits of a 16-bit number as Boolean variables and use each bit as a Boolean variable. So we could access bit number 3 of that variable, for example. This is not the case. Today's computing has advanced so much that it is no longer necessary to use space for information so minutely. In our case, the values will also come in a 16-bit integer, making our work much easier. Therefore, we will always use number. Just like in the previous case, what value should it send for on, and what value should it send for off? In our case, we wanted it to set the lighting to maximum, as we are working with 255 levels. This is also important. If we leave it by default, this button will refresh with the configuration we have in our connection. We will see this later. So let's not touch it for now, and we will see where this is generally configured for all the objects on our screens. And finally, we have a configuration option that is also very interesting. Imagine that the variable we are working with, besides the values 245 and 0 that we have configured, has other alternative values. So when should we display this button as on, and when should we display it as off? The first option tells us to set the button to on if the value is different from off. Therefore, with a dimmer, for example, where this value changes between 0 and 255. If we select the first option, this switch will appear on with any value greater than 0. So, even with a value of 1, this button will already light up, all right? Although, when pressed, it will send a 255. The next option is exactly the opposite. Keep it off if the value is different from the one we configured for on. This means it would remain off all the time until the value of that dimmer reaches 255. This can be useful in many situations, depending on the type of interface we are designing. And we're done with buttons. Now let's see why this is interesting. In general terms, this refresh rate is how often we query Adquio to refresh the value of this device and this variable. So, let's close this. We'll bring the button into our group of elements. And we'll see that within our connection, when we configured our Adquio light, we have a refresh time at the bottom. It's refreshing the values every 3 seconds. This is too much. Let's set it to 1 second. Okay? We do this in the connection where we configured our Adquio. 1 second is a good refresh rate. So, if we configure it here, for all the elements on the screen that don't have their own configuration and have left it at 0, this will be the reference value used for refreshing. And speaking of refreshes, let's see one more thing. We confirm this, save it with the parameter set to 1, and exit from here. This is also important, especially when we have a lot of elements on a screen that are being refreshed from a controller, in this case, Adquio. Within the configuration of our panel, we also have a crucial option, which is to refresh the values of this panel only when it is visible, when it is in the foreground, when the user is looking at it. Why is this important? Imagine that we have configured 10 different panels on our screen, and each of those 10 panels has 100 variables displayed to the user. Those 10 panels would be showing a total of 1,000 variables to the user. If we try to refresh 1,000 variables per second from Adquio, we might overwhelm the controller or slow down the refresh rate because there are too many variables to read from the controller. Okay, so the way to make this optimal is by checking this value. This setting tells our dashboard or our editor to only refresh the values of the panel we are currently designing when this panel is visible. Therefore, if there are 100 variables on this panel, those 100 variables will only refresh when this panel is selected and visible to the user. If we switch to another, this one will stop refreshing, and if the other panel also has this option configured, only the variables of that other panel will be refreshed. Okay? Very important when you're designing complex interfaces. Very well. So, regarding the refresh, we are finished. Let's continue looking at objects. This first palette we have in level 1 contains all the basic objects. Okay, in the second, we will see the more powerful objects, and we won't look at the third and fourth palettes much because they are for extremely complex things. Let's continue. We have another object that allows us to visualize variables. It's also interesting, so let's take a look at it. As always, we must connect it to our controller. This is something that might happen with this editor. We get here to configure the memory address and can't find how to do it because this option is different from what we already know. Here it is. We go back to what we already know. We'll set it again as variable 1, and that it's from Adquio. We test it. Turn it off, turn it on, turn it off, turn it on, all synchronized. Back to editing. We then have our value displayed. As you know, we always set it to 255. And as you can see, it is showing it. What interesting options do we have? Well, we can obviously modify the width and height, the refresh time that we just saw in the previous element, the text color, its alignment. As you saw, it was centered, the font size. We have 3 fonts. The last one is for the Russian language, which doesn't interest us today, but we have the default, which is a standard font, and we have digital. Let's see what digital looks like so you can see it. As you can see, it's a segment display. Okay, if we set it to green, it would be the typical look. Let's go back. And down here, we have a super interesting option. Remember that when we were talking about exporting values in Adquio, we mentioned that values could typically be exported directly in the native formats of the variables. If, for example, we were working with screens or with Adquio SCADAs, both the screens and SCADAs had tools to transform them before displaying. This is precisely that tool. Imagine we have a variable in Adquio that is multiplied by a 100 because it's stored in an integer and, in contrast, has 2 decimals. Therefore, it was multiplied by 100 to preserve those 2 decimals. This object already allows us to add a value to the variable we've received to display it or to multiply it by a value. In our case, not to multiply, but to divide by 100. Dividing by 100 is the same as multiplying by 0.01. So, we have the option to transform the value, in this case, by dividing it by 100 before displaying it. Let's leave it that way, so you can see what that 255 turns into. We also have the option to decide between which values the variable must be for it to be displayed, and if it's not within those values, it won't be displayed. Okay, in our case, we leave them at 0, and in this way, it is deactivated. Here, we can put the degrees Celsius symbol, the euro symbol if it's a currency, etc. We can also decide how many decimals our number should have. If, for example, we are displaying a temperature, it is common to show it with 1 or 2 decimals. Since we've divided it by 100, let's set it so that it has 2 decimals. We confirm it, and you see that now the number that was 255 before is now 2.55. Correct. So in this way, we can see that what we mentioned in the previous chapter is objective since our screens allow transforming the values that come from Adquio before displaying them to the user. Therefore, it's not necessary to do this during the export from Adquio, where we could also convert variable types. Very good. Let's continue with the various objects that might be of interest. The next object is an analog instrument. We can select the type of instrument we want to place. Let's choose, for example, this one, and connect it, as always, to our variable. We will see that we can choose its size, whether we need to multiply it by something, the range of values it should display, and if we want to add any symbol, for example, the same as we mentioned in the previous case, degrees Celsius. We can also decide how many decimal places we want it to show and how often we want it to refresh. Let's just leave it as is. We'll set a more compact size. Well, since it's a gauge, let's leave it like this. It's important to indicate the range because, in this case, our values don't go from 0 to 100, but from 0 to 255. Okay? Using this multiplier, we could convert this 0.255 into a percentage simply by setting the correct multiplier value here. Okay, the symbol, the same as before. If we want to add degrees Celsius, if we want to show decimals in the ranges, and how often we want it to refresh. Very well. We see that we now have an object that shows the values we are getting for illumination with a needle. This is not usually used. We've already seen the sliders in the previous chapter in quite some depth. The dials are quite outdated in our opinion, and you can select from 3 types of dials. Okay, you can use them if you want. We can decide, the same as before, the range of values. Let's connect it. So you can see how it works, just like the potentiometers or dimmers. We have the option to choose when to send the value, either at the end of the movement or during the movement. We also have the option to hide it, to hide this control when a variable contains a specific value. Down here, we have the configuration for this, when it should be shown, when the variable has a certain value, and when it should be hidden, when the variable has a different value. Now we have it connected. Let's set it to this size. And as we can see, it's a potentiometer, but instead of being linear, it's circular. Let's test it. As you can see, I'm doing it with the mouse, but on a touch screen, it would be done by touch. It's working perfectly. This can be interesting if you are creating a DMX-type control where you have a bunch of controls similar to these potentiometers at the bottom. Let's go back to the editor. The next object you will never need, I believe. I have never used it. It has not been useful to me. The next object can display text. It is a static text. That's it. For example, control value, control level. As always, we can choose the text color, the font, and the font style. Normal, bold, italic, or bold and italic simultaneously. Let's leave it as normal. It does not connect to a variable because it is a static value. Therefore, it is text that we write and allows us, for example, to indicate that this is the control level value. When executed, as you can see, it is simply a label, text to place anywhere on our screens. Very good. Frames are containers. They serve to draw boxes that, for example, contain a set of values. To draw this frame, at the top you have the width size, border color, border thickness, and so on. It's important to know that they are not containers. What we place inside will not move when the frame moves. It's simply a drawing around our existing objects. We can also choose the background color and transparency. What I recommend, and we will see this later, is to design your interface with a more powerful tool that allows you to create a beautiful interface and then simply place it here as a background. Therefore, all these boxes can be created in Canva, Photoshop, or any tool where you feel comfortable designing. So, for creating a very simple interface, these frames can be used. But if you want that interface to have a certain visual quality, I recommend not using them. All right, we won't do it. Images can be very useful as they allow us to set a background image. As I mentioned earlier, we can then place our objects on top of it. To set a background image in this designer, we have 2 very different options. The first option is to use this image. If I click here, it will allow me to select the image I want to use. If this image is the same size as our screen, then we can make it cover the entire screen. Several considerations regarding this. First, we need to know the resolution of our screen. I can tell you, for example, that a 4-inch screen is 400 by 400 pixels. A 10-inch screen is 1280 by 800 pixels. An industrial 12-inch screen is 1024 by 768, and a 32-inch screen, for example, is 1920 by 1080 pixels. Therefore, if we want to use images as background, we should generate them exactly in these sizes with a small exception. Depending on whether we have the top and bottom bars visible, this size should be slightly smaller in height to leave space for the bottom bar. However, if we hide the top and bottom bars, which we will see how to do, then we can use the full screen size for the user interface. All these commands to go back, switch to the application manager, etc. would be done with gestures. Depending on the type of screen, this can either be done or not. Some screens allow us to do this within the operating system itself, while in other cases it's not permitted. Similar to previous examples, we can associate it with a variable to hide or unhide it. An important point about these types of images and the option to hide and unhide them, you'll see this resource used quite a bit in various examples throughout this course. Imagine you have a series of objects on your screen, and you want these objects to be able to be activated and deactivated on demand. For example, a slider or a potentiometer. The potentiometer doesn't have the option to deactivate via a variable because it wasn't designed that way. So how could we prevent the user from touching or clicking on that potentiometer, either via touch or mouse? By placing a completely transparent image directly over that object. If this image is visible and on top of the object, it prevents the user from interacting with it. Hence, they cannot modify it. If this image is invisible, then the user can access the object beneath. For example, we could require pressing a button and entering a password to be able to touch an object. This action unlocks the object by changing the value of a variable. Now, let's move on. We won't select any images at this moment because we'll address something else important later. Let's see how to remove the top bar. This top bar can be useful while we're working because it indicates the correct connection with our controller through these icons. But once everything is functioning, it's unnecessary to display it. To change this behavior, we have a Toolbar Settings option here. We can disable the top bar. Let's save it, and you'll see we have more workspace now. The top bar has disappeared. The bottom bar, as mentioned earlier, depending on the type of Android we're working with, may or may not be usable. Let's now return to images and select, for example, the wallpaper that all our screens have. The Adquio image, let's say we want to place it over this button to demonstrate what we mentioned earlier. We'll say it's connected to the same variable, number 1, from Adquio. And for this image to be visible, its value should be 255. The value is greater than, for example. Let's set it to greater than 0. Very good. If we execute this now, as you can see, since the value is greater than 0, it's visible. Conversely, if we lower this to 0, it disappears and allows us to click on the button. Imagine the power this has for hiding or unhiding objects. Great. So, we've now finished the first tab, and with this, we conclude Chapter 3.1, where we've seen the basic controls that can be used to design interfaces for our control screens. In the next chapter, we'll look at the next tab of Advanced Controls, where we can see that most of these basic controls can be highly customized. See you in Chapter 3.2.